All right, let's dive right into this explainer. Today, we're looking at something pretty wild, how engineers are literally building a synthetic animal from the ground up. When we normally think about artificial intelligence, our minds immediately go to digital stuff, right? We think of chatbots, large language models generating text, or some code just running quietly on a server. And honestly, if a chatbot hallucinates a weird fact or makes a typo, the stakes are pretty low. But what happens when you force that intelligence to physically navigate our extremely messy, completely unpredictable real world? Because a mistake made by a 4,000-pound vehicle moving at highway speeds, well, that is an entirely different reality. So today, we are unpacking exactly how you build an autonomous machine from scratch. We're talking about giving it eyes, a nervous system, memory, and a completely unfathomable supercomputer brain just to survive in physical space.
To really wrap our heads around this technology, we have to start with a quote that kind of resets our entire baseline. Elon Musk states here, Tesla is arguably the world's biggest robotics company because our cars are like semi-sentient robots on wheels. I mean, just think about that phrase for a second. Semi-sentient. He's not talking about a car that just stays in its lane using some basic sensors. No, he's describing a machine that actually perceives its environment, makes rapid-fire localized decisions, and continuously learns from its physical experiences, exactly like a living creature does. If you're just looking at the vehicle as a way to get from point A to point B, you are completely missing the underlying technological revolution going on here.
We really have to shatter the old paradigm with this one. The traditional public perception is that this is simply an electric car company pushing battery tech. But the reality? It's actually a real-world AI company. The metal, the glass, the wheels, honestly, those are entirely secondary. They're just the physical shell, kind of like an avatar, for a highly complex, biologically inspired neural network. The software is the actual product here, and it is actively learning how to survive, maneuver, and operate safely in incredibly chaotic human environments. So here is the blueprint of the synthetic animal we're going to build today, connecting all these seemingly disconnected pieces of software and silicon. We'll be hitting four key areas. First, the synthetic visual cortex. Second, the matrix of auto-labeling. Third, building the dojo brain. And fourth, the humanoid future. Let's get right to it. Okay, part one, the synthetic visual cortex, processing the world through an artificial retina. Let's start with the sensory inputs, the eyes and the nervous system of our machine. In our own human biology, light hits our retina, travels to the back of our visual cortex, and gets organized into a cohesive picture of reality. Well, this system replicates that exact biological process. It uses cameras and code to create what is called a vector space. Now, the absolutely crucial thing to understand here is that the AI is not just looking at the world like a flat photograph. Instead, it takes raw, two-dimensional camera images and mathematically projects them into a top-down, fully 3D environment. Think of it kind of like the cars constantly hallucinating a perfectly accurate 3D video game of reality all around itself, in real time. This space contains the exact depth, position, and velocity of the curbs, the signs, and the other cars. It basically becomes the machine's internal, undeniable reality. So how does that transformation actually happen in the moment? It all starts with raw video streaming in from 8 different cameras simultaneously, completely surrounding the vehicle. But raw pixels are basically useless without context, so multi-scale neural networks instantly scrutinize these images. They're extracting everything from tiny subtle textures on the pavement all the way to the vanishing point of a distant highway. Finally, it stitches all of this together to output that unified 3D vector space. And guys, this is an absolutely massive computational leap. Taking 8 separate, flat, totally disjointed camera angles and seamlessly weaving them into one singular God's eye view of the world requires just an astonishing amount of real-time processing power. Now, this is super interesting. Notice how the system uses a feature queue to actually remember an object, even if, say, a massive semi-truck temporarily blocks it from view. As humans, we naturally have object permanence, right? If someone walks behind a wall, we obviously know they didn't just cease to exist. But early self-driving software would literally just forget a car if it got blocked by a passing truck, which obviously caused the car to react super erratically. By caching features across space and time using a spatial recurrent neural network, this synthetic animal is literally developing a short-term working memory. It's actively tracking objects in its mind's eye. It selectively writes to its memory map, keeping perfect track of cars, road lines, and pedestrians, even when they are totally hidden from the camera's actual view. Moving right along to part two, the matrix of auto-labeling, building out the memory and imagination. So as we look at our next biological organ,
let's explore how we actually train the imagination and the memory of this AI. Just having the neural networks isn't nearly enough. You need an absolutely massive amount of clean, highly diverse data to train those networks effectively. And the real world is, well, it's incredibly chaotic. It throws bizarre edge cases at you constantly. Just think about the absurd things you might see while driving. A couple running with a dog on the shoulder of the highway. Sudden, massive pedestrian crowds crossing a street totally erratically. Or an articulated truck suddenly dumping a massive pile of snow directly onto your car's windshield, temporarily blinding the cameras. You simply cannot write a traditional line of if-then software code for that. You can't just type, if snow falls from a truck bed, do X. Hard coding logic completely breaks down in a world full of infinite, unpredictable edge cases. Which leads to a massive, massive hurdle for the engineering team. Seriously, how do you train an AI on things it has almost never seen? How do you prepare a synthetic brain for a literal 1 in a million scenario, especially when the whole point of neural networks is that they need millions of examples to actually learn anything? Well, here is the fix. The old way of doing this relied on literal armies of humans, painstakingly watching videos, manually drawing little boxes around stop signs and pedestrians, frame by agonizing frame. It was painfully slow and super prone to human error. The real breakthrough was shifting to procedural simulation and auto-labeling. They essentially built the Matrix. Using neural rendering, they constructed a totally photorealistic, simulated universe to teach the AI. Because the system controls every single pixel of the simulation, the computer instantly knows the exact velocity, depth, and identity of every object perfectly, without a human ever having to touch it. They can artificially spawn, say, 1,000 moose on a virtual highway in the middle of a simulated blizzard, just to teach the car exactly what a moose looks like from every conceivable angle. It creates a virtually endless stream of flawless, auto-labeled training data. It's brilliant. All right, part 3, building the Dojo brain, the supercomputer fueling this whole synthetic animal. So to process all of this simulated and real-world video data, you need an unfathomably powerful brain. Because you are processing billions of complex video frames to teach this network, traditional processors just bottleneck immediately. The solution? Design custom silicon from the absolute ground up. The physical scaling here is just incredible to look at. They designed the D1 chip purely for machine learning. No legacy hardware getting in the way, just pure compute and unprecedented bandwidth. Then, they integrate 25 of these onto a single training tile, pushing 9 petaflops. 2 trays of those go into a cabinet for 100 petaflops. And finally, you hook 10 of those cabinets together to create the exapod. They are all seamlessly connected to operate as one giant unified brain capable of 1 exaflop of compute. To put that into perspective, an exaflop is 1 billion calculations per second. It's a scale of processing power that is almost hard for the human mind to even grasp, completely removing any of those bandwidth bottlenecks. And that massive number on your screen, 1 million. That represents the staggering amount of individual training nodes working simultaneously inside a single exapod. It represents a total paradigm shift in computing. It allows these incredibly dense AI models to iterate, learn, and improve from video data in a matter of hours instead of days or weeks. It basically creates a massive, compounding loop of intelligence. The faster the supercomputer processes the data, the faster the AI learns, getting smarter at a pace that even human engineers can barely comprehend. It is quite literally the ultimate high-speed training ground for our synthetic animal. And that brings us to part 4, the humanoid future. Giving this synthetic brain a bipedal body? Finally, we reach the ultimate realization of all this technology. Think about it. Once you've built a synthetic visual cortex that perfectly understands the physical world, and a massive supercomputer brain that has learned how to fluidly navigate it, why in the world would you restrict that intelligence to just a car? The Tesla bot, codenamed Optimus, represents a profound shift. It is powered by the exact same full self-driving computer and uses the exact same autopilot cameras as the vehicles. It is an incredible concept of modularity. The car and the robot share the exact same mind, only the physical avatar has changed. And the mission here is highly specific. Deploy this embodied intelligence to navigate the human world and completely eliminate dangerous, repetitive, and boring tasks. Suddenly, it becomes very clear that the car was literally just the first physical shell for a much, much broader intelligence. And this is where the technology transitions from being just a really cool engineering feat into a profound macroeconomic paradigm shift. Consider this quote from Elon Musk. Given that the economy at its foundational level is labor, is there any actual limit to the economy? Really think about what that means for us. Capital equipment, the machines we build, they are all fundamentally just distilled human labor. Everything in our economy is constrained by the number of human hours available to actually produce it. But if you remove that human bottleneck entirely by deploying millions of autonomous, continuously learning synthetic animals to do the heavy lifting, the traditional constraints on economic output begin to dissolve entirely. If AI provides essentially infinite labor, the cost of goods, services, and construction could absolutely plummet, reshaping the global economy from the ground up. I want to leave you guys with this final, really profound thought to chew on as these synthetic animals start entering our daily lives. What happens to society when physical work becomes an option, not a requirement? We are literally watching the foundation of real-world AI being built layer by layer, right from the raw silicon up to the autonomous humanoid. It is an absolutely fascinating journey, and it's happening right now, reshaping the world around us. Thanks so much for joining me on this explainer, and I will catch you on the next one.